Let's talk about calling contracts next. We have touched upon this before a little bit. When you call another contract within Solidity, you basically create a new transaction to this new contract. It won't be a fully new transaction, but an internal transaction. The difference is that the internal one is linked to the main transaction, which was calling your contract, and all internal transactions are executed at the same time, sequentially. This is important to remember, so calling another contract will not create a new pending transaction. We have seen the use of the low-level call functionality before for the address type. This is one way to use it. You provide the transaction parameters, like value gas, and the ABI encoded data, and you can call any smart contract address. Or you can call normal addresses, externally owned accounts, EOAs, that are not smart contracts, just to send ether to them. And this is what we did in our first contract, if you remember. And in this case, you just don't pass any data. But let's focus on the smart contract calls for now. So you can provide ABI encoded data in the rounded brackets. This would contain the information of what function to call and the function input parameters in ABI encoded format. Solidity also has a way actually to encode this using abi.encode. And there's also a static call instead of the normal call. And the static call won't allow any state changes. So basically, you can only call pure or view functions. But there is actually a better way to do all of this. Instead of using these low-level calls, we can just use the contract type. Let's take a look. So instead of address type, I recommend you use the contract type for addresses that you intend to call any functions on. So this could be either the actual implementation. So here we could use our ERC20 contract implementation as a type, or it could just be an interface. So here ERC20. Usually if you are calling your own contracts, you can just use the contract type directly. And if you're calling someone else's contract, then an interface is usually the way to go. So then calling the contract can be done with Solidity functions. You can see here we can just call transfer on my ERC20 contract. And this will create a new internal transaction sent to the address stored in the my ERC20 contract variable. The same way we can just call view functions to read the state of another contract. So here we read balance off on the some other ERC20 contract variable. So this here will basically use the low-level call, or in the case of view functions, static call functionality. But I think we can agree that this is much more readable, and all the details like ABI encoding the parameters like toAddress or amount will be done by Solidity automatically. You can also pass transaction parameters using these contract calls. This is one thing people often confuse. You have transaction parameters and then you have the function parameters. Those are two different things. Well, technically speaking, they are actually not too different. Both actually will end up as transaction parameters, but the function parameters are handled separately by Solidity and automatically are ABI encoded and put into the correct format and then used as the data field in the transaction. But keep in mind that Solidity, and usually in front-end tools as well, the functions parameters are usually handled separately in the syntax. So function parameters will be in rounded brackets and the transaction parameters in curly brackets. And you can even create new contracts using the contract type. This can be done with the new keyword. And of course, you have to provide the input for the constructor. The result will be the contract type of the deployed contract with the address of the newly deployed contract. Not really so difficult, right? Okay, so before we use this for our stablecoin, let's talk about oracles quickly.